Okay, solving a system that has three unknowns or three variables. This looks a little bit harder, but it's really very similar to what we've done before. You're going to be adding or subtracting two equations together, trying to eliminate one of the variables. So take a look at it first and make a decision. What do you want to eliminate? And when I look at this one, if I look at these two and say, I want to eliminate y, it looks to be an easy move because all I have to do is multiply this equation by 2. So that's my first choice. I'm going to do these two equations, and I'm going to multiply this one times 2. So I put a little note up there that I'm doing times by 2, and now I'm going to rewrite that, timesing it by 2. So I get 4x plus 2y plus 6z equals 18. I'm not going to do anything to this one but write it underneath. X minus 2y plus z equals 8. Draw a line here, and I am going to just add the two equations together. Can you see that? Let's adjust it just a little bit. All right, so I'm going to add the two equations together. 5x, no y there, plus 7z equals 26. And that's a good equation, so I box it off and I'm going to save it. Now, I want to use a different grouping of these equations and do the same thing, eliminate the y. I could do these two, although I'd have to multiply this one by 3 and that one by 2. That would work. Or I could do these two, and that way I only have to multiply this one by a -3. You know why I want -3, right? Because +3 and -3 would cancel out. So I'm going to times by -3. Always put a note, right? -3. So 2 times 3, -6x minus 3y minus 9z equals minus 27. I multiplied everything in this equation by -3, and I was going to use it with this third equation, so I'm just going to copy that one underneath, just like I did in the last case. I'm going to draw my line. What am I going to do? Hope you said add. Notice the y's are going to cancel out again, so I get -10x plus, what happens here? -9 plus 2, -7z. All right, -7z equals what? 31, right? All right, I'm going to box that off. These two equations, I still have an unknown of x and z, but I could add them together, right? So let's try to do that. And I'm going to just write 5x plus 7z equals 26. When I add them together, the z's cancel. So I end up with 5x, -5x, equals -5, right? Divide by -5. What do I get? X equals 1. There's one of the variables. All right. I can go back into one of these equations with my x equals 1. Let's go into this. So if x equals 1, that gives me 5 plus 7z equals 26. Subtract 5. 7z equals 21. Divide by 7z equals 3. There's my second variable. Now I can go into any equation to get the last one. So since I have x and z, I'm going to choose this equation because x is 1. So 1 minus 2y plus z, which we know is 3, equals 8. Minus 2y plus 4 equals 8. Subtract 4. Minus 2y equals 4. What happens next? Divide by negative 2, right? And you get y equals negative 2. So I have all three answers for that system. And the x, y, and z works in all three of them.